Hi everyone, today we are going to demonstrate a project called brain tumor segmentation using deep learning or brain tumor detection using deep learning. So finally, we will be having like this interface. When you upload an 3D image, okay, we are going to segment and we're going to give which area of the brain is actually causing the tumor. So we will be showing you entire this web application, how we built and what are all the features are there within this, and how we integrated the model and everything. Before that, we'll discuss in depth how our proposed methodology we have done, and what is the existing system, and what are the research papers that we are referring, and what are the things are there in those research papers, and how we are defining our work as a unique, because we need to present something unique than the existing, and our uniqueness is performing better than the existing thing. We'll discuss all those things one by one, and then we'll in detail see how we coded all these things. So we have referred to IEEE papers. So you can see one deep graph cut model for 3D brain tumor segmentation. So this paper, when you check into this paper, if you look at into their experimental results, okay, you'll be able to see what are the data preparation they done, and they are using brats 2018. This is the dataset they are using. This paper is using dataset brats 2018, whereas our project we are using 2023 and 2024, the recent brats dataset. Brats is actually a source of the brain tumor, maybe a body which collects, a medical body which collects, okay, the brain tumor images. And if you see the results they are mentioning, okay, how much they are getting DSC, and different models they are trying, same thing. Okay, whatever you are seeing here, we have made it as a proper document, and so that you can understand it very easily. So before moving further, we will try to understand what actually brain tumor is. Brain tumor is abnormal growth of the brain cells. So any tumor you take, for example, that there will be a cell and its position will be there, but it will try to grow uncontrollably. Okay, so that case we call it as a tumor. And in brain tumor, mainly there are two things: benign and malignant. Benign doesn't spread; it will stay there in the particular area, but whereas malignant will try to spread throughout the body, so which is cancerous, and benign is non-cancerous tumors. What they will do, what actual brain tumor will do, when the brain cells will start to grow uncontrollably, it will put pressure on surrounding tissues. Just imagine, our brain contains so many subparts, so each will be having their position, their size, their uh, performance. Okay, they will be doing their own task. Some will try to control the emotion, some will try to control the action on the body, some will try to control our what is it? Some variations, like it may be growth hormones, like related stuff. Okay, hormone control, what you say. So every part of brain is having its own task. So if some part of brain start to do some uncontrollable growth, it will try to keep pressure on the remaining cells. Okay, as well as nerve system will get disturbed, so it will cause an issue. So this is what brain tumor is. So why tumor is so much dangerous? Because brain is like a CPU which controls all the functions in the body. It ranging from nerve system to hormone system, everything. Everything will almost be controlled by our brain itself. So like it will try to go headache, seizure, memory loss, vision issues, and speech difficulties. There are so many things that being controlled by this brain tumor, and it will directly impact on those parameters. Whereas malignant is there, which spread from one organ to some other organ also. Inter organ impact will be causing, because it will try to spread with help of blood also. So that's a very dangerous. So it makes malignant very threatening one. And if we detect it at early stage, we can do something about it. But if you detect at later stages, or say almost the stage 3 and stage 4, which is very impossible to cure it. And what are different type of brain tumors are there? So mainly here you can see primary tumors as well as secondary tumors are there. Under primary tumors, we can able to see gliomas, meningiomas, pituitary adenomas, and ependymomas. Okay, so these four different comes under primary tumors. So they originate in the brain. Okay, so that's why they are called a primary. And what about the secondary tumors? Are that to brain from other things, okay, maybe lungs or some other skin thing. From here, if it's spread to brain, and it will try to manipulate the brain or infect the brain, we call that as secondary tumors. What are the possible treatments are there when it comes to brain tumors? One is directly surgery to remove the tumor part and cure the issue. And the next one is radiation therapy to destroy the cancerous cells, keep healthy cells as it is. Then comes chemotherapy, that is chemical is used to do the therapy to kill the tumor area. And then targeted therapy, again this is again a drug related thing, which is used to attack the specific cancer cells. And then immunotherapy, so here we'll try to cure it indirectly by increasing the immunity of the person. Okay, the immunity of the cells that can fight against the tumorous viruses or infection. Okay, so we call this immunotherapy. Whatever we are seeing here when it comes to cancers, all of them are, if they are at lower class, the problem is at stage 0 or stage 1, can be solved properly. But when it crosses level 3 and 4, it is very hard. So now where can AI come in act, and how it will be helpful for us? Those things we will try to discuss. First, how can AI help brain tumor detection? First one is, we can do early detection by looking at the MRI scans. Okay, and why we should go for deep learning or AI tools, whereas doctor can do it. The problem is, we are not saying humans are not capable, but the problem is when the data will increase very huge, when the variation will increase to very huge. Let us take the variation ranges in 10 lakh, 20 lakh, 10,000, 5,000, not in thousand, even in hundreds also. As a human being, we have restriction there, we can't analyze much data. Okay, so for example, some doctor knows even 3 to 4 type of tumors he treated. Okay, with his experience, he can classify that properly. Okay, but when it reaches to 100, as a human being, he will be in confusion. So that high accuracy deep learnings can analyze n number of different cancers, not only one or two or four or five, hundreds, thousands, lakhs. And according to the type of cancer, the treatment can be decided properly. And then the faster diagnosis can be done faster when you know properly about the disease, what is happening there properly without any confusion. Even automation in treatment, automation in surgeries, okay, any type of therapies, maybe chemotherapy or immunotherapy, whatever therapy, or it may be surgery. So there also AI is being used to lot scale, and which reduce the needs, sorry, cost effective. So which will try to reduce the cost. Okay, uh, and here the most important stuff is, for example, MRI scan. So how much you give it for MRI again and again? Oh, nearly in India, as for our small research, it will range from 9,000 to 15,000. It depends on the locations as well as the tool the hospital is being used. So that much costly is that. So that can be reduced by doing with the help of deep learning. Role of deep learning in 3D brain tumor segmentation. So now in our case, we are trying to segment, we are trying to say which particular area is having a tumor. We are not just saying is it a tumor or not. We are trying to mention where is that tumor, how much area is that tumor is. Okay, and by doing this, even we can try to understand the depth and surface, how much deep maybe that cancerous is spread, how much wide area it is having that space. And what are the different type of deep learning models that we have, like 3D unit is where VNet is there, CNN RN hybrid models are there. What they will do, they will automatically segment the tumors area, distinguish between healthy and affected tissues. Okay, assist surgeons in planning precision and safer surgeries. So when we can able to say what is the depth and area, surgeons can easily decide how it can be handled properly. How AI can solve the problem early, little bit early. As I said, with these tumor things, if you handle them early, you can solve the problems. But when it crosses some stages above the control, you can't do anything about it. So even a small and early stage of tumors can be detected from MRI scans, which are very hard to analyze by human, but deep learning models can do that, and it can reduce the human error and manual analysis. Okay, and which will support continuous learning from the new data. Okay, when you train, it is like a baby. When you train with more data, it will learn better in its experience, with its experience. Okay, so which will increases the prognosis, survival rate, as well as quality of the life of the patient, and even it will reduce the cost of the treatment. So now whatever we are discussing here are all about the papers that we referred. So we are referring to IEEE papers. So what they are speaking about, what data set they are using, what methodology they are using. I think you can see here these two papers. So this paper I shown you. So in this paper, what is there exactly? So we have extracted the information that we need from this paper after studying it. Same thing, after studying this IEEE paper, so we have extracted so many features out of this paper. Okay, and then we have trained our model, then we compare what they are getting, how they are getting, what our results are, one by one. So first let us discuss about this paper, deep graph cut model for 3D unit segmentation. So this paper uses dataset called BRAS 2018 dataset. So why we are doing this, why we are studying the existing papers? Because once you study the existing papers, you can define your methodology better than the existing. So we need to improve our work, we need to improve our models. So we can do only after we know what is existing. We need to understand first what is existing, what the existing things are there, and what is the research gap. We need to fill that research gap. And this BRAS 2018 dataset, which is publicly available. Okay, so in our case, we are using the recent dataset, BRAS 2023-24 dataset we are using. And when it comes to model, they are using T1 weighted contrast enhanced, and the dataset they are doing like 285 scan images they are taking for training, 66 are going for validation. We call this step as a dataset splitting, but in our case it is very used. We are working on a lot of data, and they have prepared the data using the BRAS. And what are the pre-processing steps are done in this paper? So these things, whatever the 3D images that you are seeing here, they will be in 3 dimension, in not in JPG PNG format, they will be in NII format. Okay, so we need to that they are nothing but 3D numpy array, mathematical array format they will be. We need to extract them, we need to normalize them. Okay, and we need to augment them. What is mean by augmentation? Sorry, this paper is speaking about augmentation and normalization. What is mean by augmentation is bring some variation into the existing image, maybe rotation, maybe intensity, maybe flip of the image. And in this paper they are trying to crop images, they are reducing the image size, that is array size, you can say. So multidimensional, multiple frames will be there. As a 3D, it will not be single image. Okay, it will be having slices, like slide, you say. For example, if you move a slide faster, it will look like a video, no? So each angle is like an one frame. So they are defining 3D unit architecture, and they are using 500 epochs. They are using Adam optimizer. Their learning rate is 0.01 and with decay is 0.0001. Okay, batch size 2 to scans they are taking together for training. And cross entropy, sorry, weighted cross entropy as a loss function they are calculating. And graph integration, they are trying to integrate deep graph cut, that is DGC model for segmentation. So finally, if you look into the performance evolution, so they're getting a dice score around 0.92, 0.83, 0.53, 0.82. Dice coefficient DS is one of the parameter. Okay, so you can see all other remaining models DSA scores different are there, 0.92, 0.94. But remember, working with these 3D images, 3D data is really very hard, because their size will be very huge. It is hard to process in your normal systems. You need to have very good and very efficient GPU systems, or you can prefer to go with Google Colabs, or you can prefer to go with Kaggle notebooks, who provides free GPU for you. And there we try to check what is there in the paper 2. So that is brain tumor image segmentation using deep networks. Okay, before moving further, if you are new to our channel, you can subscribe our channel. We will be coming up with like these videos based on AI, ML, data science, NLP, computer vision, and Python based. And we are looking further to come up with few more technologies which are far better. Okay, we even try to bring you some good videos which you can use it as your final year project research. Okay, you can approach us with your own ideas if you want. We as a team will be helping you in building it. Will be helping in your research, will be helping in your documentations. So we will help you in your complete research stuff, from selecting the topic for and then to analyze it. Okay, and then to build it according to your requirement. So if you have your own models defined, if you are having your own proposed methodology defined, we'll build according to that. You can come up with any idea, we will try to solve if it is solvable. So here in this paper, training set 335 images or cases are being used, and 125 cases are used for validation. Okay, so then pre-processing and augmentation, you can see images almost same data set it is also using. Whatever the above used, almost same data set they are using. So 3D CNN augmentation, cropping, rotation and mirroring they are using. Okay, and finally, same thing they are presenting again and again. In that paper they are mostly concentrating on 3D unit itself. It is a normal unit, Now their performance, when we see the proposed ensemble model, its accuracy is 0.75, 0.96, 0.906, 0.846. Different cores, they are trying to build a model to detect different core of a brain tumor. And now when we go through all this, they are mainly concentrating on UNet, 3D UNet, and they are trying to use it as it is. So in our case, what we are making different, what we are defining so unique is we are making hybrid 3D unit architecture. In our hybrid, we are trying to use, I'm showing you the code that we done. So we are generating so many features for us. Okay, not only dice coefficient. So you can model, wait, give me some time. We have trained it here. So our model, we are adding attention layers as well as transformer blocks in the middle of our 3D unit architecture, which is very helpful and which will lead us to a better result. So this is our 3D unit architecture. You can see we are integrating our transformer block as well as we are trying to integrate our attention layers multiple times. Attention 4, attention 3, attention 2, and attention 1. So we are trying to make our 3D unit architecture as an hybrid architecture which can lead to a better result. So we even getting better result after training it. So we are training it for 100 epochs, but after 84 or 85 epoch or around 90 epoch, it will try to stop early stopping, because from there accuracy will not increase further, so it will try to stop there. But when we train till there, we are going to get, again you see here what is positive from our side is we are training it with lot more data, 425 training data set, and we are using 2023 brats 2023 and brats 2024, and we are using two data sets. We are not working on single data set. Two brats 2023 parts are being taken and we have trained it. So now what I'll do, you can see here, so like this the images, one data, one MRI scan will be having all these angle changes. So this is the annotated data set or the segment and the image pair. So now here what we do is we are going to train our model, and when you train for lot of epochs, we have stopped it in middle because each epoch will take around 462 seconds. So we have trained already for 100 and we have all those parameters down. Okay, you can see, but you need to train like this. You see here how many parameters we are generating for each epoch, not only one parameter to analyze. If you see our precision here, it is 98.52, sensitivity 98.52. All these are actually our classification report parameters. Okay, then you can see specificity, validation specificity is 99.51. Accuracy you see is, accuracy is 98.66 and 98.41, which is far better than the existing system. Precision is 97.95. Okay, training precision, training sensitivities, training specificity. Okay, then validation accuracy, validation specificity, everything is too good. So when we train for 100 epochs, how we get the results is that we already made it into logs, and you can see here how it looks exactly. Training accuracy, okay, for each epoch. So 85, 86 it stopped. Okay, so then by using this model, if we implement it on any given frame, how accurately our model prediction is happening. So this is a ground truth, middle is a ground truth, last one is a prediction. Almost we can able to get a better result. Okay, so this what we are testing our model. We are not just saying with word accuracy वगैरह, we are implementing on images, we are getting the results, we are comparing with the ground truths. Okay, so many images, so many slices we have tested, and then you can see single slice. For example, one MRI scan, in MRI scan that rotates all around your body and it will scan in all angle. Only one angle if I am taking, I can able to even detect properly there on a single slice. Okay, so can able to get a better result here. Okay, so here also we are trying to segment out. So here some blank are there. If there is nothing, the prediction will also be nothing. So like this, one brain in all angles it will be captured. Okay, so this what, if you upload a single slice of the brain of the 3D brain, you can able to get the result like this. So when brain moves or rotates, according to that we can able to find where is the brain tumor. Is that clear? So this is a way to handle the data. Okay, so this is a complete 3D unit architecture, hybrid unit architecture, which accuracy is much greater than the existing papers, more than 98, 99, 98, 99. So once we build that, what we do with it, we're gonna save that model, and then we are going to interface it with our web application. So that web application is built with help of HTML, CSS, JavaScript, as well as in the backend we are using Flask. So how can I say like I have built with all those stuff? So can you see here 3D unit 23? Wait, when we save our model, we need to load it here. So I'm loading here just for the confirmation purpose. I'm going to show you this. Can you see this model? I am loading it. So I need to load the model. When you upload any 3D slice, 3D brain tumor slice, I should be able to segment it with the help of this, which is having 0.995 accuracy, and then the result can be displayed in the web application. As you can see here, when you click, you can upload the slice, okay, T2F, and you can able to get the segmented area as a result. So to build it, you need to build a better model first, then you integrate into a website. And here we can do more things, not only displaying this result, you can make it like a login and register. If you come up with your own requirement, you'll be having some imagination with you. Just think what can be done. Okay, if you want us to do something extra to this, we will do it. Like you can comment out. Okay, so we can just say what we can do extra here, whether we can find out the region area, whether we can find out the depth of it, and whether we can assign the proper size tools can be used to treat or to do the surgery, or whether we can give an idea of type of approach to be used, maybe not surgery, maybe immunotherapy, maybe some exojet therapy, chemotherapy, what can be done. So like that, so many things we can give as a result. So if you have any idea, you can just text to us through comment box. Okay, so this is all about our project. Now at last we are providing so many projects, and like that mainly we concentrate mainly on research for PhD and MTech or some B final years. We ever want to do a research on like this concept, you can approach us. Okay, if you want support in your project, we can help you. Our team is always ready for that. Okay, we will help you from proposing methodology, from mentioning you the existing system to building it, and next integrating it, next documentation, then implementation of this code in your system, as well as we will train you to do it. It is not like we are taking control of your system and do it. We teach you, we train you how to run it, and then we explain you what we are doing. Then you will be having entire information with you. You will do it yourself. You can do it on yourself, a new data, on a new data. Okay, we will try to educate you more than providing just a project. Thank you very much. We will see in the next session with few more good project. Thank you very much. Don't forget to like and subscribe us, and if you want to contact us, please contact to the number given below. You can just call us or WhatsApp us, or you can visit to our website, or even if you are from Bangalore, you can visit offline to our office and you can discuss further about this. Thank you very much.